All right, so for these applications, we are going to set up inequalities first. So set up things that look like up here and then solve them to answer the question. So for any like equations and inequalities that we're setting up, we always want to make sure we understand what our variable is representing. So here there's a band playing a show, and they are going to play for a like solid $200 plus 25% of the ticket sales. And then we have to find the ticket sales. So what we're looking for is going to be our X. All right, so ticket sales are number of tickets sold. And then just be aware that, so this 25% of ticket sales is going to, like that little calculation is going to involve X. So we're tying our variable to this here, but the $200 is not dependent on how many tickets, it's just a flat $200. So when we set this up, so it'll be so the band will make $200 plus, and then 25% of, so we turn 25% into a decimal, so 25 divided by 100 would be 0.25, and we would multiply that by, oh my gosh, I can get to, the number of ticket sales, which we don't know, that's our X, so we just multiply 0.25 times X, and then this, whoops, so this piece right here represents the total, will represent the total money that the band will make, so $200 plus 25% of the ticket sales. And so then to set up the other side of my inequality, we're using this last piece, that the band wants to receive at least $500. So at least $500 would mean that $500 is the smallest amount they want to make. So if they only made $400, that would not satisfy this. If they made $600, that would satisfy this. So we can use that kind of reasoning to say, well, the total money they're going to make needs to be greater than or equal to, so they could make exactly $500. So we're comparing the total money to that value of 500, kind of that boundary that we want to be greater than. And then from here, we can solve this inequality to figure out what is that number of ticket sales that we for sure have to sell in order for this band to make the money they want to make. So we'll draw our line, and then we can subtract 200 from both sides. And then divide by 0.25. And so X would have to be greater than or equal to 1200. So what that tells us is that, so remember X was number of ticket sales. So the number of ticket sales needs to be more than 1200. So you would say the band needs to sell at least 1,200 tickets in order to make $500. All right, and then similar, this next one, so a salesperson earns a salary of $700 a month plus 2% of the sales. So even though we have like the per month and like the sales here, we want to pay attention to what our variable is going to be. So we're being asked what are the sales going to be. So again, X is going to be so like number of sales. Okay, it doesn't really get specific about like what we're selling. So the $700 per month is not dependent on the number of sales, so that's a constant, a flat $700. And then, because this whole problem is looking at just 1 month, and then 2% of the sales, so that is dependent on X. And just like the previous one, so we take 2 out of 100 to get that decimal, and then being 0.02, and we'll multiply that by the number of sales. So $700 plus that 2% times the number of sales. This would represent the total income or total money that the salesperson is making. And then they want to know how many sales, so what would X have to be in order for this total to be at least 1,800. So at least 1,800 means I want to make more, 1,800 or more. So my total money when comparing to 1,800 would have to be greater than. And then we would solve that to figure out how many sales are necessary to make this happen. So subtract 700. And then 1,100. And then divide. So we get 55,000. So that means our sales, whatever we're selling, must be at least 55,000. All right, and then so this would actually represent the amount we make from sales, because we're taking 2% times the amount we're going to make from the sales. So you must have at least $55,000 coming in sales, and then 2% of that plus your 700 would give you the 1,800 a month at least. All right, and then compound inequalities. So if we have a pair of inequalities joined by either the statement and or, we can either, so if it's an and, we can like rewrite it as a compound, so put them together in one statement, and then or they'd be going separate directions, and the graphs will help us visualize that. So to be able to write like this compound inequality, the single one, we would need to solve each one separately. So if I add one, and then that would be negative 27. And then divide. So I'll point out that that rule that we said in the first video up here. So make sure that, so a common mistake is understanding that this only applies when we're dividing by a negative. So in this case, there's a negative involved, but 3 is the number we're dividing by, and that is positive, so I'm not going to apply that rule there. So that would be x is greater than negative 9. And then over here, so minus 7, so 2x is less than 12, and then divide by 2. 6. So then what this is saying, so this was an and, that if I look at a number line, so negative 9 would be down here, and then we can like plug in our 0 as like the center point, and then 6, so kind of to get some bearings on where we're sitting on the number line. So this left one greater than negative 9, so it's an open circle, and then I'm going to be going to the right because it's greater than, and then x is less than 6, so again an open circle, but less is going this direction. And since it's an and, I'm only looking at the space where those two things would overlap. So even though technically this inequality would keep going and this one would keep going, their overlap exists only between negative 9 and 6. So that's how we're going to write this compound inequality, is we'll say x can be any number in this in-between space. So it's going to be larger than negative 9 and smaller than 6. So right now we can see how this inequality matches here. And then even though this is flipped, as long as like the greater than side is facing X, the greater than side is facing X. I can reverse inequalities like that as long as the symbol is staying consistent. So it's just kind of putting both those ideas together in one more concise inequality. All right, so just for the sake of length of video, go ahead and try this one and check the solutions. And then you can ask me about it when I come back if you're stuck. Do one or example, and then I think I'll have you do the rest with the solutions as well. So if it's an or, we do the same thing. So -1, and then 3x is less than 14. And then so x would be sorry, I lost my spot. Oh shoot, I'm doing the wrong one. Sorry. I'm gonna do this one. Okay. So add 2, and then 4y would be greater than or equal to 16, and then divide by 4. So y is greater than or equal to 4, and then I'll do this inequality over here. So I'll add 4 to both sides, and then 3y is less than -13 plus 4, which is -9. And then I'm dividing by +3, so I keep the symbol going that direction. And remember, this was an or. So if I go to my number line, so we're looking at 4 and -3. So if I put 0 here, 4 would be over here, -3 would be about right there. And then this is saying that y is greater than 4. So that's going this way, and it's a closed circle. And then y is less than -3 with a open circle. So less than is going this direction. So this is an or because my inequalities are going in opposite directions. So there is no overlap. So I would not be able to write an or set of inequalities in a concise way because they're going opposite ways. All right. So go ahead and try the other ones. I will point out for these last ones, you are going to end up with an overlap. So maybe I'll do this one. So if I subtract 1, so 3x is less than 14, and then divide by 3, x is less than, that's about 4.67. And then over here, so I'm dividing by a negative. So we're going to have to reverse that inequality to go the other direction. Right, so it's greater than, so now it flips to less than because I'm dividing by a negative. And then x will be less than now -13 divided by -2, which is a positive 6.5. So if I go to my number line, so 4.67 and then 6.5. So x is less than 4.67, so that's going this direction. And then x is also less than 6.5, so that's also going this direction. But if it's an and statement, that means I'm only looking for the overlap. So if I go this direction, this section right here is not overlapping with this section here. So we are actually not going to include 6.5 in the overlap. So just this portion will satisfy this and part. So we can essentially just say, if this is an and, we really only need to write this because this part has like extra, like they aren't included in the overlap. So this kind of overrides it, the x less than 4.67. And then same over here. this real quick. So minus 3, 5, and then minus 1. So 4x is greater than negative 9. And we're dividing by a positive, so I leave the symbol. So this one's an OR. So we have negative 2.25 and positive 5. So since it's an OR, that means that whatever either of these hit, so we're not just looking for overlap. So x is greater than negative 2.25 goes this way. X is greater than 5. So that just continues past. And we would include both spaces. So basically, we would just kind of focus on that one because this kind of lives inside there. So we only would technically need to write that one there. All right. So again, for these ones I skipped, go ahead and look at the notes and then just flag anything you have questions on, and you can ask me when I get back.